Okay, here is the next question on a Bohr's concept. The energy of an electron in the first Bohr orbit of hydrogen atom is minus 13.6 electron volt. Then which of the following statement is or are correct for helium plus? Okay, what they are saying is helium plus. Helium plus means what? It is a hydrogen like species, single electron system, right? So first question is the like four options are given. Let me check like which of these options are correct and why it is correct. So question option A says that energy of the electron in a second Bohr orbit is, right? If you see which of the following statement is correct for helium. So for the helium, the energy of the electron in second Bohr orbit is minus 13.6 electron volt. So how energy is given? Energy is given En is equal to minus 13.6 into um, Z square by N square, right? So this is minus 13.6 and first Bohr orbit n is equal to 1 and z is also is equal to 1 for hydrogen. So that time it is En is equal to minus 13.6. So energy of the electron in the second Bohr orbit of the helium. So this will be what? For helium minus 13.6 into n is equal to 2 square and z is also 2 because it is helium atomic number. So answer is minus 13.6. So option A is correct for this. The kinetic energy of the electron in the first orbit. Now we are talking with respect to the helium. We are talking with respect to the helium plus species. So kinetic energy of electron in the first Bohr orbit is minus 54. The kinetic energy when we talk about the kinetic energy, it is we know that kinetic energy is negative of total energy, right? Energy of the electron in the nth orbit. This is what we know. So this is given as minus 13.6 of the electron in a first orbit of the helium. Means this will be is equal to z will be is equal to 2 square and first orbit means n is equal to 1 square which will be 1. So this is minus 13.6 into 4, right? So answer magnitude wise, this is going to be uh, this will be is equal to what we can say is that over here this answer is going to come with respect to this to be 54.46, right? So kinetic energy of the electron in the first orbit, like with magnitude wise, this is true, right? So what about the sign? Kinetic energy is, can I write this way, minus En, that is total energy, right? So this is also true. Like if you are getting total energy to be minus 54.46 for the nth orbit, like, or we'll do it this way. We'll do it this way. This is what we have. Kinetic energy is equal to negative of the total energy of the electron in the nth orbit. So I will write it is this, right? So magnitude is same. So although I am getting 54.46 as the magnitude of the energy in the nth orbit, minus 54.46 as the energy of the nth orbit, and negative it is. So just positive value of whatever value you are getting, that will be is equal to kinetic energy, and this is also true. Kinetic energy of the electron in the second orbit is, in the second orbit, kinetic energy will be what? This was the total energy, like energy of the electron. So it will be obviously positive value. This is also true, like because of this relation, right? The speed of the electron in the second orbit is 2.19 into 10 raised to 6 meter per second. How velocity is given? Velocity is given to be is equal to 2.19 into 10 raised to 6 z by n For helium atom, Z, Z is 2. So this is 2.19 into 10 raised to 6. This is 2. And second orbit means this is also 2, and 2 will get cancelled. What is the answer? 2.19 into 10 raised to 6. So this is the velocity. So here we have revised with this formula. We know the total energy is equal to, like, kinetic energy will be negative of the total energy, right? So all the options A, B, C, and D are correct. Okay, here is the next question. Question says that select the correct curves. Okay, if V is the velocity of the electron in the Bohr's orbit, R is the radius of the electron in the Bohr's orbit, P is the potential energy of the electron in the Bohr's orbit, kinetic K is the kinetic energy of the electron in the Bohr's orbit. So here the question is asked in this manner regarding the curves. Okay, first let's look about this. The first question is about option A is saying that it is velocity versus 1 by n. Like if you draw the curve, means this should be what? What does this relationship says, right? Straight curve. Straight line means it shows that it is a direct relation. So velocity of the electron in the nth orbit is given as velocity is equal to velocity will be is equal to minus 2.19 into z by n, right? This is constant, right? So what I can say is that velocity is directly proportional to the z by n in this case, right? So here, if you just see that, then it is inversely related to the n, or this could be written as velocity is directly proportional to z, and it is inversely proportional to 1 by n. Sorry, it is directly proportional to the z. This equation could be interpreted in this manner that velocity is directly proportional to z, and it is also directly proportional to 1 by n. Understand the difference? It is directly proportional to 1 by n and not n. It is inversely proportional to n and it is directly proportional to 1 by n. So this curve is velocity versus 1 by n, and it is a direct relation. So this statement is correct. Like this curve is correct. Next is radius. Okay, second is radius. So curve B says that radius is given as a naught into n square by z, right? But what I can say is that radius is directly proportional to the n square by z, right? So in this regard, this is radius and this is n. So this logarithmic curve which we are getting, so this says that this should be n square. So radius is directly proportional to the square of, it is directly proportional to the n only. Okay, since this is square, you will get the logarithmic curve. So option B is also correct. Potential energy. Okay, here there is a slight twist. That is what I will say. Like potential energy, what we get, potential energy is what we are getting is minus, sorry, not minus, yeah, minus kz e square by r. This is what we were getting, right? But since r is equal to what? R is equal to, it is a naught into n square by z. So what I'll do over here, I will substitute, it will be minus kz, will substitute for r e square. This will be z upon n square. And if you take these constant out, then what I can say is that minus, like, kz e square upon 1 upon n square, and it is minus, right? Potential energy. So potential energy is inversely related to 1 by n square, and it is negative, isn't it? So this is 1 by n. Since it is negative, where it will go? It will be decreasing. So this option C is also correct for this, isn't it? Then kinetic energy. Kinetic energy is what they have mentioned is decrease with n, right? Decrease with n. So kinetic energy, in terms of kinetic energy, we can say that kinetic energy is also directly proportional to z square by n square. Here we can say that it is kinetic energy is inversely proportional to n square, right? So this is positive. It is also decreasing. So option A, B, C, and D all are correct.